Welcome to Unit 1.10, where we talk about types of discontinuities. Now, a continuous function is like drawing a function and never lifting up your pen. But a discontinuous function is like drawing a function but lifting up your pen in the middle of it. Now, there are three types of discontinuities. The first one you have is a whole. Next, you have a vertical asymptote. And lastly, you have a jump discontinuity. Now, a whole is removable. It's removable because if you were to fill in the hole, it removes the discontinuity. But a jump discontinuity and a vertical asymptote is non-removable. So it stays the same. It does not move, or it cannot be removed. Let's do an example. Now, before we begin, there's very important things to remember that will help you solve many equations. In a function, if it is a fraction, you know that it's a discontinuity when the denominator equals 0. If you have a function and one of your factored values cancels out, then you know your discontinuity is a whole. And if your denominator does not equal 0 and has a value under it, then the denominator that stays will be your vertical asymptote, or VA. So now let's look at an example. If I had the function f of x equals x squared minus 8x plus 12 over x squared plus 3x minus 10, the first thing I would have to do is factor. So on my numerator, the first thing I have to do would be x minus 6 times x minus 2. And in my denominator, I would have x plus 5 and x minus 2. Now we can see here that our x minus 2's cancel out. So, like we said before, if it cancels out, then we have a whole. So this can be shown as whole at x equals 2. We know this because if we were to set x minus 2 to equal 0 and solve for x, I would have to move my 2 over and get a positive 2. That's how I know my whole is going to be x equals 2. So now I'm left with x minus 6 over x plus 5. And like we said before, the denominator that does stay and that doesn't cancel out would be known as our vertical asymptote. So we have a vertical asymptote at x equals negative 5. And we know this because if we were to put x plus 5 to equal to 0 and solve for x, I would have to subtract 5 from both sides, and get x equals -5. And these all are discontinuities. Thank you for watching.